Hi there, this is a lesson on the periodic table and its layout. Feel free to pause or repeat anything that you need to hear again or take your time in writing down. As you look at the periodic table, the order of the elements should show a pattern to you, and that is that they are arranged in the order of increasing atomic number, which is the number at the top of each element's block. And as you'll remember, as we've talked about before, that number indicates how many protons each element has. As we look at the periodic table, there are various patterns that emerge that are very intentional. The first is called a period, which is a row on the periodic table from left to right, as indicated by these arrows. And you'll see that the first three periods have fewer elements in them than the subsequent periods. You'll also notice the periods correlate with the numbers on the left. So there are a total of 7 periods for the largest elements. A group goes up and down, and these are the columns on the periodic tables, and they're sometimes called families, and they're grouped as such based on their chemical behavior, which has to do with the number of electrons they have in their outermost shell, which we call valence electrons. Periodic law states that when elements are arranged in order of increasing atomic number, there is a periodic repetition of their physical and chemical properties. That is, within a period, when you move left to right, the properties of the elements change. However, when you go down to the next period, those periods or those properties will repeat from row to row. When we look at the periodic table, we often see colors indicating different categories or classes of elements, and these are metals, as indicated in left, or yellow, nonmetals indicated in blue, and then metalloids indicated in green. If you notice a stair-step line, that kind of breaks up the metals from the nonmetals, and then those metals that are around that stair-step line have both metal and nonmetal properties, and so they're indicated as metalloid. On your periodic table, if you have your blank one, you should take a moment to color it in and indicate these three classes. Notice that hydrogen on the top far left is also a nonmetal, and it is grouped over in group number 1 due to the fact that it has just one valence electron, not because of any metal properties. The properties of elements are largely dependent upon their electron configuration. In other words, how many electrons they have in their outermost shell. The nucleus of an atom, as you know, holds the protons and neutrons. The first energy level or shell can hold 2 electrons. The second can hold 8, and the third can hold 8 as well. Each of these shells can be subdivided into what are called orbitals. That is covered in AP chemistry, and basically it's different movement patterns of the electrons around the nucleus. So quick review, rows are periods, groups are columns, and if you notice here, the first 2 elements in the first period, there are only 2 of them, and then in the second period there are 8, and then in the third period there are 8. And this pattern is interesting because, as we notice here, those first 2 elements, hydrogen and helium, remember that first shell holds just 2 electrons. And the second period has 8 elements and holds 8 electrons. The third period also has 8 elements and holds 8 electrons. So kind of an interesting pattern there. For the purposes of this class, with respect to numbers of electrons in shells, we would not go beyond element number 18, which is argon, because beyond that, the arrangement of electrons becomes a bit more complicated. Until now, we've talked about atoms being neutral, meaning they have equal numbers of protons and electrons. However, sometimes the number of protons and electrons are out of balance, and this would create what we call an ion, which is a charged particle. So you could be talking about the same element, but one that has different numbers of electrons. Ions can be negative or positive. Negative ions are called anions. Positive ions are called cations. When an anion gains electrons, it becomes negatively charged, and it would also have a larger radius because of the fact that the electrons are in addition to the ones it already had, and so it would take up more space. Cations become so by donating or getting rid of their electrons, or sometimes they're just taken from them by atoms with a stronger pull, and therefore their radius would shrink. Taking a closer look at some of the groups, let's look at group 18, your noble gases. In a colloquial sense, every atom wants to be a noble gas with respect to its electrons. Noble gases are full outer electron shells, so they're stable. And in the atom world, you could consider them as being happy. As a rule that you learned about in the atomic structure notes, the octet rule states that if the outermost energy level is full with 8 electrons, then the atom is stable. Now, their exception to this is hydrogen and helium with only 1 energy level. That smallest shell that only holds 2 electrons, they would be stable with just 2. So an atom will always, quote unquote, find the easiest way to get a full shell. Obviously, they don't want anything, but it makes it easier for us to understand. So neon is a great example. It is inert, it does not react, it has a full outer shell. On your periodic table, note the alkali metals, which are group 1. These just have 1 valence electron. And what's significant about the valence electrons is that these are the ones that are involved in chemical reactions. Now, if you only have 1 valence electron, you definitely don't have a full shell. And so to get a full shell, you either pick up 7 electrons, which is a whole lot, or lose the one that you have and then kick you down a shell, and then that one would be full. So alkali metals always give away their electron, and they're very explosive when they do so and can react violently just in water. So for example, sodium in group 1 on the periodic table would donate or get rid of 1 electron, becoming positively charged and acting like neon. So on your periodic table, you should note that the group 1 elements, the alkali metals, would have a +1 ionic charge. Group 2, the alkaline earth metals. These have 2 valence electrons, and so in order to get a full shell, they could either pick up 6 electrons, which again is still a lot of work, or lose 2 electrons to go down a shell and then have a full energy level. So when they give away 2 electrons, these elements are also fairly explosive, not quite as reactive as the group 1 elements, but still quite reactive. So for example, beryllium, if it lost 2 electrons, then it would actually behave like helium, having a full first shell with just 2 valence electrons in it. Then it would be, quote unquote, happy. And so on your periodic table, note your group 2 alkaline earth metals as having a +2 ionic charge. Group 17, the halogens, so way over next to the noble gases, these have 7 valence electrons. And so in order for them to get a full shell, all they need to do is pick up 1 electron. They're so close. So the other option is to lose 7 electrons, but that would be quite a big deal for that to happen. And as we'll learn about in the subsequent lecture, you'll see that that's quite unlikely. So if they can steal an electron from another atom, then everything would work out quite well. And this actually makes them very corrosive because they tend to corrode other elements by stealing their electrons. So for example, chlorine. Chlorine is only 1 electron away from being stable like argon. And so if it takes an electron from, say, something like sodium, then it would be stable. And for example, you've heard of table salt, which is sodium chloride. And the reason why that forms is chlorine will take an electron from sodium, and now each of the elements are quote unquote stable, but now they're also oppositely charged and therefore attracted to each other, therefore forming salt. So on your periodic table, note the group 17 elements as the halogens and write that they have a -1 ionic charge. Lastly, group 16, not really a named family because it's kind of got a composite composition, but do note that these have 6 valence electrons. And in order for them to get a full shell, the simplest path is to pick up 2 electrons. They could lose 6, but again, that would be quite a bit of work. And these do steal electrons from other elements, and so they are also corrosive. And you've probably heard of something being oxidized. So for example, oxygen will cause rust in elements like metals, like iron. And so that you would say that the iron has been oxidized or it rusts, and it does so by taking electrons from other elements. And so when oxygen takes 2 electrons from other elements, it now has a full outer shell and behaves like neon, its nearest noble gas. So it's very stable. On your periodic table, please note that group 16 elements have a -2 ionic charge. So that is all. I hope that's helpful. And please remember, you can go back and listen again and rewrite or write down anything that you need.